Hi, guys. Hi, Dylan. Hi, Vanessa.
Good to see you again.
Good to see you again. Okay, guys, I'm changing the time. The meetings are going to say 7 o'clock, but when I'm actually going to start will be 7:15. There's a reason for that. I teach a class right before this. And literally speaking, when I started the meeting right there, that's how long it took for the recording of that particular class to be uploaded. And what happens, I found, is it won't upload in the background. I get an error message. So I've got to have an extended period of time that I'm going to be able to get that uploaded and then start this class. Does that make sense to you all?
Yep.
Is there any major objection to that? Nothing? Hearing crickets, I'm going to go on. There's another major thing that is going on in the class, and that is the classes are running Sunday to Sunday. In other words, it's an online class. So each one of the experiments is open as of a Sunday, and you have until the next Sunday at midnight to finish it. Any questions about that? That's why when I sent out the announcements today, announcements on Sunday, I gave you assignments for August 30th, which is next Sunday. Okay? I gave you those assignments, which include the post lab and the results for chem and physical properties, as well as the pre-lab for density. And guys, I'm selling something in my kitchen, so I'll be right back, okay? Is everybody clear on that? If you were confused on that, I gave you until midnight tonight to do the pre-lab on this experiment. Any questions on that?
No.
It's going to alternate just like it did in intro. You'll do the pre-lab for the experiment that is assigned that week, and you'll turn in the results and post-lab from the previous experiment. How are things going for you guys this semester? You getting pretty much rocked in here, or you kind of hating this online crap?
I'm not a fan.
I got to tell you, I'm not either. And I'm even more not a fan of the online as opposed to the live online. So it's really, really and truly, I had maybe today between my two sessions in Zoom, I maybe had 18 to 20 of my 40 students. So it's kind of like I don't develop any kind of relationship. And that's much to the detraction of you guys, because if I develop a rapport with you, I'm kind of rooting for you, and I root for all my students. And I try and get you guys to get through it. But if we have this relationship where we don't have a relationship, it's hard to develop that rapport. That's one down thing about it anyway. Okay, I'm just gonna piddle around here for a second. I told the rest of the group 7:15, so that is when we will officially begin the Zoom meetings. I'll probably open the Zoom meeting just after the other class recording gets uploaded.
Can I
Okay,
ask you a quick question on the notebook?
yeah, I'm here.
So for this lab, we have the data table and then we have the post-lab questions. Can we just put that on the next page?
Okay, wait. You're trying to do this. It's Dylan, right?
Yep.
Dylan, were you paying attention last week when I was talking about the notebook?
Yeah.
Okay, I was talking about specific sections.
Yep.
The objective, procedures, data table, calculations, and results. Right? You remember that?
Yeah.
Okay. Now, you don't have to answer the post-lab questions. The post-lab questions are only there to kind of aid you along in answering the post-lab questions online. They don't have
Okay.
anything to do with the notebook itself.
All right. Thank you.
All right. And remember, Dylan, I want a separate section for calculations and the data table.
All right.
Any other questions, guys?
I'm sort of missed last week, so the notebook's going to be an important part, right? And I have to
No,
upload
it's
photos
not.
from it
It's
or no?
really not an
Okay.
important part. I think the total number of points is somewhere around 1,800. The notebook's 100 of it.
Okay, yeah,
Counts
it's
no
important.
more or no
Gotcha.
less than a experiment.
Okay, gotcha.
Okay. And basically, Roger, what I'm really going to do is you're going to be submitting these every week as you complete the experiments. There is a folder that you're going to submit them to. Okay.
Too
But the
easy.
major part of your notebook grade I'm going to count one. I'm going to basically tell you, okay, this week, guys, do your notebook really well, because this is the one that 90% of your grade for your notebook is going to come from. The other 10% is going to be whether you submitted them and whether you submitted them, you did a conscientious effort to submit them, okay? That makes sense, Roger?
Roger, yeah, I got you.
Okay, I got how many people in here? I got 6. Okay. And go here. Oh, there we go. Did I lose any of you from the screen sharing?
Nope.
Okay, good. I'm just sitting here trying to twiddle my thumbs waiting for 7:15 to roll. 5 more minutes, guys. I'm assuming that I'm going to get a whole bunch of people in then. Do you have any questions about what you've been doing in lecture? Basically, it's been a review so far. You won't really get into anything new until we start talking about the gas laws. And pretty much you probably haven't even gotten into empirical formulas or stoichiometry, which are the hard parts of the first test. Any questions, guys? I'm feeling kind of useless. Ooh, 4 minutes left. So how long can he tap dance? Clue. No time. I don't tap dance. Have you guys looked at the video for this yet?
Yeah.
No, I haven't.
Okay. Vanessa? That was
Yes.
you? Okay, basically, easy enough to find course content. Go down to the, and you'll be happy to know, Vanessa, you're not the only female in the class tonight, so.
Oh, that's good.
See chemical, physical changes and properties?
Yeah.
Click on that. Everything gets populated for that particular laboratory. So you're going to go to the video for, click on that, and the YouTube video from Dr. Musgrave will pop up. Okay?
Cool. Thank you.
This is an important one. This one is important because this is going to show you what happens in the video for the chemical reactions. You're not going to get data any other way than from looking at the video. So you have to watch it. And it's semi-entertaining. You get to see chemicals reacting with one another or not reacting. 3 more minutes. Anybody found any good restaurants in St. Pete recently? Anybody waitressing that, or waitering that does not want to recommend their restaurant? This is how I get to the places that I get to eat. It's on student recommendations.
I don't know
Sound good?
about St. Pete, but Frenchie's on the beach is pretty good,
Really?
especially original. Yeah, I like the original Frenchie's. They have a super group there that's killer.
Where's
and I
that
think
at?
they're doing.
In terms of Treasure Island?
So it's downtown Clearwater on
Yeah.
Gulf to Bay. You just take Gulf to Bay across, and then when you get to that roundabout, you're gonna keep going, and then you're gonna head north on the beach line, and then
Okay.
it's right next to the Sand Pearl.
Give it a try next time I'm up there.
Yeah, it's a good place. Highly recommended. And then the Rockaway right down. There's like 3 of them around there, but the Rockaway over there has killer calamari.
My wife loves calamari.
Hmm.
Good to know. Rockaway and Frenchie's, great.
Well, it's a Frenchie's Rockaway. There's like
Oh.
3 different Frenchies, and they serve different places. So the original, you definitely got to start there first. That's the best place.
Okay. Much better. What's the place? What, Caddies? Or is Caddies for old people?
I haven't been there
That is
yet.
really good.
I'm sorry, Caddies is good?
Yeah.
I haven't eaten there. I've just been there to partake of our adult beverages. Okay, this may be it. All right. I'll wait the 1 more minute. This is worse than waiting for my steak to get done on the grill. Good thing I did. Blake came. That now gives us 8 people. 8 out of 24 is not bad. Actually, they scared me. Believe it or not, guys, they put extra people in here. They put extra people in the lab, not that they could because it's online. I think there are 29 people registered for the class. 7:15, yay, we can start. Sooner we start, the sooner we get done. Okay, I mentioned it to the people that joined me around 7 o'clock. 2 things. One of which is, I would like to start these meetings around 7:15. The way Zoom has it in its computer schedule, I can choose to start the meeting at 7 o'clock or 7:30. If I want to really start the meeting at 7:15, I have to choose the 7 o'clock. Now, what that means is that I will open it before 7:15, but I'm not going to actually start the lecture until 7:15. The reason I'm doing this is, again, twofold. One of which is it gives me another 15 minutes to relax between doing my lecture and doing the lab lecture. And more importantly, what happens Zoom gets really confused if you're trying to convert one video while you're giving another meeting and recording in another media. So Zoom gets confused. That means that one of my evening lectures may not have gotten converted. That's why I have to hold off. It took 15 minutes to convert the hour and a quarter lecture in on the, to convert that in Zoom. That means that I can't start at 7 o'clock, so it has to start at 7:15. The other thing involves a email I sent to you. Because this is an online class, the dates are set up Sunday to Sunday. The dates are set up Sunday to Sunday so that the experiment opens on one Sunday, closes on the next Sunday. By that, I mean the pre-lab for this lab should have been done last Sunday. I kept it open until midnight tonight, but the pre-lab should have been closed midnight on Sunday. Now, this coming Sunday, you're going to have the density lab, pre-lab, as well as the results and the post-lab due by midnight Sunday. Really and truly, it shouldn't matter one way or the other to you. You still got a week's time to do this in. The only difference is basically you won't have had my lecture if you try and do the material before it's due. If you try and do the material from Sunday to Tuesday, you will have lost out on the lecture I have. Any questions on the 7:15 start or the Sunday to Sunday thing?
No.
Again, let's do this coming Sunday, pre-lab for density, results post-lab for chemical and physical properties. All right, to start with, and I'm going to get out of here again. If you're in your course and you're up in course content, that will load all of them. You want to get into chemical and physical changes and properties, which is down there somewhere. The first thing on the chemical and physical properties and changes is the video. Each one of the laboratories, I believe, has a video that accompanies it. And basically, it gives you a picture of somebody going through the exact steps you need to do the experiment. It's not critical except this lab. This lab has no data in it. So the data you're going to have to get from watching the video. And basically, you're going to click on it. It's 15 minutes out of your life. And basically, you're probably not, you're going to be able to hear it when you, can you hear this, guys? Can you hear the video?
No.
No, we can't
All right.
hear it.
You will be able to hear it when you upload it in your own computer. Basically, what he's going to do is he's going to go through, I think there's a series of 7 of these experiments. He's going to explain what he's doing as he does it, and he's going to show you the results. Okay, any questions on the video?
No.
It doesn't seem to serve any purpose for me to go through it if what's going to happen is you can't hear it. Okay, the other thing. I kind of like to show you got a PowerPoint, I believe, a video on YouTube that talks about double replacement reactions. So if you go into the actual quiz for the results, and again, everybody can see this. Can everybody see this?
Yep.
Yes.
Mm-hmm.
So as you start the quiz, you're going to get, for each one of the experiments, you're going to get a question. You're going to get choices. There may be more than one answer that's correct. So choose as many correct answers as you can. So you're going to choose whatever's correct for what you observed. Then you are going to, sorry, I got to move this. Then you are going to have to choose whether it was a chemical or a physical process. And that's basically the same way down for all 7 of them. So that by the time I get to 14, maybe there's 8 of them or 9, okay? By the time I get, there are 8 of them. By the time you get to, you're done with that portion of it. Then what it asks you to do, he gives you the substances that are combined. What you have to come up with is you have to predict the products. And if you notice, it's giving you some semblance of magnesium chloride and hydrogen. You have to balance it correctly. Remember, hydrogen is a diatomic molecule. Things of this nature are going to become important to you. Okay? And then you're going to go through these. Each one of the reactions has a prediction of the products. And you're done. Questions on that?
No.
Okay, all right. Follow the instructions that are given, especially in this laboratory. Result or post lab. Basically, they're just going to be questions on, multiple choice questions on scenarios. Start quiz. Okay, you see, these are just word problems trying to differentiate whether something's a physical or chemical change. Any questions on what you're supposed to do for the results or the post lab?
Nope.
Okay, now I'm going to give my little presentation, hopefully, if I can find it. Okay, we're going to go. Okay. Okay. Sorry, I have to find something. I thought I had it in here. Apparently, I kicked it out. Okay. Generally speaking, I don't try and do any kicks, any fancy things in these particular PowerPoints. It's just straightforward. So basically, what you are looking for with these observations, you're looking for an evidence of a chemical change. Definition of a chemical change is that you have changed the chemicals from one thing into a brand new chemical. So basically, the observations you're going to use are the fact that the properties for the set of chemicals that began are going to be different from the properties of the chemicals that you end up with. So new compounds are going to have new properties from the old ones. Okay? If you take copper 2 chloride, which is blue crystals, and you dissolve it into clear water, what happens is the solution will turn blue. Is that a chemical change?
Yes.
Okay.
Would it
You
be a
have the
physical-
blue crystals. What do you think will happen to those blue crystals if you dissolve them? What's going to happen to the color of the water? Vanessa.
Oh, the water will turn blue.
But if you evaporate
it's
all
from
that water, you're going to end up with the blue crystals again, right?
Yeah.
Have you changed the copper 2 chloride at all?
No. Okay,
Oh.
so it's not chemical.
Dissolving is not a chemical process. It is a physical process. Basically, the color of the solution is simply coming from the color of the blue crystals.
Okay.
On the other hand, say, hold on a second, guys. Hey, Taylor, what's going on? Okay, Taylor, I'm sorry, this is, what did do you have any, who are you from? Oh, Taylor, I'm sorry, I'm in the middle of teaching a class right now, okay? And actually, I don't think I called you, I thought I emailed you. That was a while back then. No, that wasn't. That was. I'm fine. I'm fine. I don't have any problems. I had a missed call, and I thought that. Never mind. That's what it's. You have a good night too. Bye. Okay, I apologize, guys. I'm sorry. I have to answer those because sometimes it's a student that hasn't gotten into the class or something of that nature. And that happened to be a person that is in charge of the labs in Hillsborough. So I apologize for that interruption. All right, let's do a second example. You have a clear solution that's composed of potassium thiocyanate, and you mix it with a clear solution of iron nitrate, iron 3 nitrate. You get a blood red color. Is that a chemical change?
Yes.
Okay, is the answer sitting out there? Let's think
No,
about
it's-
this. Let's think about it. You had two colorless solutions. So their property is they don't give a color. Then when you mixed them, you had something that did give a color. So most likely, because you have changed the properties, this is a chemical change. Cobalt 3. I swear to God, guys, I'm sorry about this. I put animations in here, and apparently they didn't stick. Cobalt 3 compounds are red crystals. When you dissolve them in water, they turn into a red solution. Hypothetical question. If the cobalt metal is placed into a clear colorless solution, after 20 minutes, the solution has a noticeable pink color. Did a reaction take place? Well, what I'm going to argue to you is the fact that because the solution was colorless and now it's pink, that some of the cobalt metal has been reacted with to make cobalt ion. And that cobalt ion is now in solution and has developed a pink color for the solution. Is this kind of making sense to y'all?
Yes.
Color changes solid. What color is the Statue of Liberty made out of? Dylan?
Copper?
Okay. What color is copper?
Metallic, almost bronze, I suppose. That's the best.
I'll give you
comparison I can-
bronze. Metallic,
Yeah,
I won't give
they're
you
more like
metallic.
bronze.
Roger, are you acting like a typical male and don't know any colors?
I mean, the best way I could describe like copper would be like a lighter bronze.
Bronze, okay. All right, but what color? Roger, well, I got you. What color is the Statue of Liberty?
Well, it's blue. Isn't that from oxidation?
Yeah, but copper's brown.
Green.
Statue of Liberty is made of copper, yet the Statue of Liberty is blue. Is it not exhibiting a different property? Roger.
Yes, it is.
So therefore, if it's exhibiting a different property, it's likely a chemical reaction happened.
Correct.
You guys, I hate that you guys haven't been through a lot of stuff. If you heat up magnesium, magnesium is a bright, shiny metal. After the heating, what happens is you have a very fine white powder. Are the properties different?
Yes.
Has a chemical reaction taken place?
I'm gonna say yes.
You'd be very safe in that. How many of you have done the volcano experiment? You take baking soda and vinegar, right? You take baking soda and vinegar, and what happens? Come on, somebody had to have done it out there.
It explodes.
Dylan?
It explodes.
It doesn't explode.
Bubbles, fizzes. and
Bubbles,
doesn't-
fizzes. Okay?
Doesn't produce hydrogen, I think, if I'm remembering that correctly.
All right. I'll answer that. I'll give you an experiment. The next thing it says, when you put a lit piece of wood, a lit splint above the air above the reaction, the flame is extinguished. If it were hydrogen, what do you think would happen? Remember the Hindenburg.
Definitely go down like it.
Basically, if it was hydrogen, then the flame would be increased because you're adding more fuel there, a more explosive fuel. But when you put a lit splint above the air, the flame's extinguished. When you put a lit splint above vinegar, the flame still stays there. When you put it above the powder, again, the splint stays lit. So you have evidence of bubbles forming. You have evidence that the flame gets extinguished when you put a splint over top of it. Do you have a chemical reaction?
Yeah.
Anybody know what the gas is?
Carbon dioxide?
Carbon dioxide. Baking soda is sodium hydrogen carbonate. And vinegar is an acid. You mix the two of them together, you make carbon dioxide. Okay, you do hydrogen peroxide. It's a clear liquid. If you treat it, by the way, this one is called, has anybody ever seen the elephant toothpaste? It's a
No.
cool experiment. Nobody's seen the elephant toothpaste?
Was that the big mess one?
Yeah. Okay. There's a commercial. There's a commercial on with the little girl that's trying to do a science project. And the science project goes out of hand and she gets splashed with all kinds of stuff. Have you seen that commercial? She gets splashed with
Yeah.
kind of like a green liquid. That's actually, in any case, that's the elephant toothpaste experiment. All right. When you put potassium iodide into hydrogen peroxide is a clear liquid. Potassium iodide is a white solid. You get bubbles. You get many, many bubbles. Okay? When you light a splint and extinguish it and put it in the atmosphere above the reaction, the flame relights. However, if you put that splint and light it, extinguish it, put it over the liquid, nothing happens. Put it over the white flame or put it over flame, nothing happens. Do the clear liquid and the white powder have the same gas in them? Guys?
Mm,
Okay.
Well, it had to come from somewhere.
You're right, Roger. It had to come from somewhere. How did it get created?
It was a byproduct of the reaction.
It was a byproduct of the reaction. Actually, what happens is hydrogen peroxide, when you put potassium iodide next to it, it gets converted to water and oxygen gas. That's why when you light it, extinguish it and put it in above the air above the reaction, the flame will start up again, because it's kind of like when you blow into a fire, and to get the fire to go up more and more, you're putting more oxygen in it. But yet, if you do the same thing over the hydrogen peroxide and the same thing over the white powder, the flame doesn't reappear. That must mean that something has happened to create oxygen. Chemical reaction. Sometimes you can form a precipitate. Okay, you add a clear yellow liquid of lead nitrate to a clear solution of sodium chloride. A yellow solid appears. Did either solid or did either solution have a solid in it?
no.
Yet, when I mixed them, something must have happened to create a chemical that had the property of being insoluble. Before, everything was soluble in water. Now we have something that's insoluble in water. So therefore, what we have is a change of properties. Therefore, we have a chemical reaction. Change of temperatures, both hot and cold. Be careful. If anybody's had a sprain, does anybody know what I'm talking about with cold packs?
Yeah.
Yeah.
Cold packs are nothing more than a bunch of powder of, I believe, ammonium chloride, and in the separate compartment is water. You smack the bags to break the seal. The ammonium chloride dissolves in with the water, and what happens is that is an endothermic process. In other words, the bag gets really cold. That is why you can put it on sprains and stuff. Hot packs used by hunters have the same thing, only the difference in the hot packs is they get hot. They're exothermic dissolutions. Temperature change can be a sign of a chemical change or a physical change. You need to know what's going on and what you're adding. If you're adding an ionic compound to water, that's just dissolution. If you're adding an ionic compound to something else and you're creating heat, then it comes from a chemical change. It's an iffy situation. Okay, now remember I told you, you are going to have to look at the substances and be able to predict the products. From that, you're going to have to draw upon your memory regarding the reactions: single replacement, double replacement, acid base, and combustion. So we have magnesium metal and we have HCl. What type of substances are they? Arthur? Magnesium, Arthur.
Well, magnesium is a metal.
It's a metal. Is it a atom? Is it an element or is it a compound?
It's an element.
Element that's neutral, right? There's no
Yep.
charge around it, correct?
Yes.
Okay. What type of compound is HCl? Don't pay attention to the man behind the curtain. What type of compound is HCl? Yes, I know it's an acid, but what are all acids? Your choices are ionic, covalent, or polar covalent.
Wasn't it ionic?
It's an ionic. So do you remember what happens when you take a neutral metal with an ionic compound? Do you remember what type of reaction that was? By the way, guys, this is an in-depth part of the chemical reactions that you should be getting in your lecture, but you may not be getting it into this depth. Part of doing chemical reactions is recognizing the reactants to see what type of reaction you have. Anybody remember? I'll throw it out to the class. Anybody remember what happens when you have a neutral metal reacting with an ionic compound? What type of reaction is it?
Is it a single?
Single replacement. So in a single replacement, what happens? Vanessa?
The magnesium would switch places with the hydrogen because they're both considered positive.
Yep, absolutely. Magnesium switches places with the hydrogen. The hydrogen then becomes the neutral entity. How does hydrogen exist in the world?
Diatomic.
H2. So basically, what I'm going to look at this is I'm going to look, this replaces the H. So I have magnesium linked with the Cl, plus I have H2. All of that comes from recognition of what my reagents are. Now, the other thing is, you need to
Professor.
balance the products as well. Yes, magnesium is linked with the Cl, but you got to figure out what charge is on the magnesium, what charge is on the Cl to determine what the subscripts on that are. Again, if you have a diatomic compound, have no fear of ice cold beer. Have hydrogen, no nitrogen, fear, fluorine, of oxygen, ice, iodine, cold, chlorine, beer, bromine. Have no fear of ice cold beer. If you don't like that, just go from nitrogen on the periodic table over to fluorine down to bromine. Those are 6 of them. You just have to add hydrogen to them. Those will all exist as diatomics. In other words, they never exist as a single H or a single F. They exist as H subscript 2, F subscript 2. We good with that?
Yes, but Professor, I just had a quick question. So
I'm
like
here.
in the past for a single displacement reaction, I had this flow chart I used for like what elements more reactive versus less reactive. So like you told us that magnesium is more reactive than hydrogen, so of course we replace it. But if it was hydrogen,
I did not tell you that.
Well, yeah, but how would we determine that? That's the
You would
other thing.
actually add magnesium to the hydrogen, or add magnesium to HCl. Okay?
Mhm.
Vanessa said you created H2. What's H2?
Hydrogen?
What is it? How's it exist?
As a diatomic.
But what is it? Hydrogen.
It's a gas.
It's a gas. So is magnesium or HCl a gas?
No.
So if you add the 2 of them together and you get a gas, what do you think the gas is?
Okay, I see what you're saying.
Well,
Um,
basically what you're doing is, that's why you have to look at the videos. Some of these reactions will go, some of them won't. You're going to be able to use different ways to predict whether they react or not. Does that make sense, Roger?
okay, so if you added hydrogen to MCl, and nothing happens, then you'd say like, oh, there's no reaction
Bingo.
and you would know that, okay, gotcha. So that's the way you want to think about it. Too easy.
Yes. Okay. Thank you for asking that, because that answered my last question. Okay. I got zinc and copper sulfate. Zinc, just like magnesium, is a neutral metal. Copper sulfate is an ionic solution. Dylan, what kind of reaction do you think this is?
Single displacement.
Single displacement. What are the products?
ZnSO4 and copper.
There you go. Again, you're going to have to figure out whether those products are balanced or not. Okay? HCl and copper sulfate. Ooh. HCl and copper sulfate. What's HCl? What did we define it as before?
An ionic bond.
How about the copper sulfate?
Ionic.
Ionic. So if I have an ionic compound mixed with another ionic compound, what type of reaction?
We have a double displacement.
Double displacement. Again, guys, do you see how you're using the reagents, the reactants? You're using them to predict what type of reaction it is first, then predict the products. Dylan, what products do you think you would get from this?
HSO4 ClCu.
Now, first of all, always put the positive ion first. So it's CuCl.
Okay.
Again, those are not balanced. In order to do this correctly, you would need to balance those reactions. Again, it's a moot point if these don't react. If they don't react, you get no products. Okay, this is a hard one. First thing, understand when you have a chemical formula, if you have a metal in it, that compound is an ionic compound. What you do is, in order to differentiate the cation from the anion, the metal is going to be your cation, everything else is going to be your anion. The only exception to this is NH4+. That's the only polyatomic cation. So, what are the types of substances? I got to see who else is in there. I'm tired of calling on the same people. Jackson, you out there?
Yeah.
Jackson, what are the type of substances?
CuSO4 is ion.
Ionic? What about sodium bicarbonate?
Also ionic as sodium.
So I have an ionic compound that's mixed with another ionic compound.
Did a double replacement.
Double replacement. What are the products that you would say hook the products together?
NaSO4 and HCO3.
Correct. Again, you would have to balance the compounds. I'm not going to balance the compounds for you right here. Is this helping, guys?
Question with that last one. What happened to the hydrogen?
It's HCO3 is an anion called bicarbonate or hydrogen carbonate. It's the same name. It hasn't separated from that.
Oh, okay. So it stayed together with the
It
copper.
stayed together with the CO3 and stayed as the anion bicarbonate, okay?
Okay.
Again, quickly, let's go through this. Okay. I got more choices. Casey. Casey, you there? Casey has logged in and now she's watching the news or Jeopardy at this point. Is Jeopardy on now? It's a college tournament. She's probably watching the college tournament.
It's a rerun.
Okay, Ty. Ty, you
Yes,
there?
sir. I'm here.
Okay. What kind of compounds are we dealing with?
Ionic.
And
Ionic.
ionic and ionic. You mix one ionic compound with another one. What type of reaction is it?
Double replacement.
So what products am I getting?
CuSO4.
No, that's what you're starting with.
Oh. NHSO4.
NH4SO4.
Okay.
What's left?
NH. Just the copper.
You said NH4SO4. What's left of the first compound?
OH.
So what's the copper linked with?
Just wait. Can you repeat that?
All right. You linked the NH4 plus the SO4. My next question to you was, what was left of the NH4OH?
Just the 4OH.
Not the 4OH. The 4 goes with the NH4,
So just the OH.
just the OH. So what do you think the copper is linked with?
I don't know. That's where I get confused after that part.
Okay. What we do is you have to split these off into the cation and the anion, right?
Right.
Okay. Ty, do you know the Flintstones?
I know of the Flintstones. Yes.
Okay. You know there's Fred and Wilma and
Yep.
Barney and Betty, right?
Yep.
Two couples, right?
Mm-hmm.
Well, they're having dinner one night and Fred looks over at Betty and thinks, hey, I'd like to have a brunette tonight. So Fred says, okay, I'm NH4. I'm going to hook up with SO4. Okay.
Yeah.
Barney doesn't want to be left out of the party, so he looks over and sees Wilma. Wilma's pretty willing and very anxious to go with him. So Barney, the CU, links with the OH, Wilma. Does that make sense
Okay.
to you, Ty?
Yes. That's okay. CuOH.
CuOH. Again, you have to get the compounds balanced.
All right.
What type is this? Kevin,
Single displacement.
single displacement. Neutral metal with an ionic, single displacement. What are the products, Kevin?
Magnesium SO4 and copper.
Bingo. Do I need to go through the rest of them? I've been sitting here doing this for about 45 minutes, guys.
Is there going to be any questions on like combustion or
This exact thing.
results? Yeah.
In the results section, you're going to have this exact thing, Roger.
Will we be balancing them?
Yep.
So are we going to do combustion and like acidic reactions as well, or is it just going to be ionic and single?
For
and
the
double
most part, it's
displacement?
just going to be single and double replacement.
Okay, too easy.
I want to see how many of these. I got this. Yeah, I do want to go through that last one. All right. This is a funky one. Anytime you mix a carbonate or a hydrogen carbonate with an acid, Believe it or not, that is an acid-base reaction. But it doesn't start out that way. What happens? You have an ionic compound and you have another ionic compound. Starts out being a double displacement reaction. The hydrogen goes over and links with the HCO3 to make H2CO3. And the sodium links with the chloride. Okay? Now you have H2CO3. There are two very stable compounds that can evolve from this. Can anybody see what those two compounds would be? Throw a guess out there. One of you for a little
NaCO3
bit.
and
What's that?
NaCO3. NaCO3.
No,
And then
the sodium
C-
chloride. The sodium chloride is going to stay itself.
Okay.
Sodium chloride is going to stay itself. I'm
I
talking
guess
about
it could-
just the H2CO3.
Well, I could turn it to H2 and then have a polyatomic ion floating around, I guess, maybe. I don't know.
No, you
That'd
can't
be
have
my
a
guess.
you can't have a negative ion floating around without a consequential positive ion. Good
Okay.
shot.
Would it be water and carbon dioxide?
Looky here. If
Oh,
we
there you go.
put the O with the H2, we've made water. We've taken an oxygen away from the CO3. That's CO2. So basically, we've made water and carbon dioxide. Now, can you give me evidence that this reaction takes place? You take HCl and NaHCO3. What are you going to see? Come on, guys. What state of matter is CO2?
A gas?
So what are you going to see?
You can hold a flame and see if it gets extinguished.
Well, you could, but what are you going to see?
Oh, bubbling.
You're going to see bubbling. All right.
Okay.
Now this is the last one I think we have. What are the substances we have here?
You have water and you have NH4
What type
Cl.
of compound is NH4Cl?
Oh, I know.
I feel like it's an acid.
No. It is an acid, but not for the reason you're thinking. It's a weak acid, but not for the reason you're thinking. Come on. What is this? Can you split this down the middle?
Yeah.
And do you have a cation and an anion? What kind of compound is it?
Ionic?
It's ionic. What do you think happens when you have an ionic compound with water?
It dilutes.
It dissolves. Is dissolving a chemical change?
No.
No.
So if you're doing this reaction, the only thing that happens is you get NH4 plus Cl minus. That's the only thing that happens. You may want to put aqueous down at the bottom. And that's all I got, guys. I hope this helped you.
Yep.
I basically, this is I didn't realize it was so dark on my screen. Basically, this is what you should be going through when you get to the chemical reaction section of this. And it's what I try and do when I teach it. I try and make you look at what you're starting with, use that to predict what kind of reaction you're going to have. And then once you know what kind of reaction it is, predict the products. That's all I got for you guys. This will be recorded. It will be uploaded into the course as well as the PowerPoint. But this is generally how these are going to get conducted for the rest of the semester. Any questions?
Nope.
I just had one quick question for going back to double displacement and single displacement. So like back in my old intro to chemistry class, I was given this chart, and basically it has like all the properties on there, like when it becomes a solid, like with the double displacement and stuff like that. It's just sort of like this graph thing. It shows like which elements are more reactive and will replace onto an ion and then leave the remainder on the outside. You know what I mean?
Are you talking about are you talking about the activity series?
Yeah, like the activity series and the solubility chart. So we're not going to use that. We're going to be basing it off like, so the question will say like, we add these two together, there's no reaction, or we add these two together, you see bubbling or whatever. So we're going to have to.
Roger, I showed you what it was. I showed you the exact quiz.
Yeah, okay.
It's going to tell you mix HCl and Mg together. What did you observe? Okay. You're not supposed to use the activity series for this because of the fact you're supposed to use the observations to detect whether a chemical reaction occurred.
I was just making sure that because I was looking at this and I was like, okay, I have this from real chemistry class, see if I could use it. And I guess I can't, and that's okay.
Roger.
Okay.
Am I in your house? Am I in your house looking over your shoulder?
Well, I know that, but I got to see the camera.
How am I going to detect whether you're using the activity series or not?
Well, I want to make sure I get the lesson right, or what the intention of the lesson was, I suppose.
And that's a good idea because you don't know what's going to appear in the final. Okay?
Too easy.
So basically, I think your data table only has maybe 2 columns. One says observations. You look at the video, you write down the observations you have, and then I think the next column says chemical or physical. Something to that effect anyway. No calculations for this laboratory. Any other questions, guys? Well, if that's the case, I'm going to drink beer and eat my chili.
Have fun.
Take care, guys. I'll see you again next Tuesday at 7:15. Jasmina, were you here for those announcements?
Yep.
Okay. And Jasmina, did you try and get into the lecture this morning?
No, I didn't.
Okay, sorry. Thought you may have. You just attended the last one, right? The 5:30 one?
I always go to the 5:30 ones. Is the 9:30 one caught up? Because I wanted to go to the 9:30 one last time, but it was like behind, so I just left.
What I got to is I got through in the morning, I got through the history. I got through the history and the conservation of mass and energy. The only thing that I didn't get through is the atomic structure. So I'm pretty much caught up.
Okay, then I'm probably going to start coming to the 9:30 ones to get it out of the way in the morning.
Please, Jasmina, if something occurred today, basically what happened is I had a whole bunch of people that didn't get the invitation because apparently I sent it to the lab rather than the lecture. I have both opened up and I hit the wrong thing. Yeah, I'm sorry, things like that happen. If something like that happens, call me. That's one of the reasons you've seen me go and answer the phone. I don't know who's there, all right?
Yeah, all right.
I got to ask you, with the last name ending in C or IC, do you have origins in the old Yugoslavia?
Yep, Bosnia.
Bosnian? Okay, I've actually been there. My origin is Croatian, but the amazing thing, Jasmina, when I was over there, it was a cinch going through the Bosnian entry point. The Croatian one,
Really?
I had to sit there and wait for 20 minutes just to get through this thing.
That's funny.
You
I've
need
never
to go.
actually been. I was born here.
I'm sorry,
One
you've
day.
never been?
No,
Never been?
not yet.
You need to go.
No.
It's a beautiful country. Absolutely
Yep, I've seen
gorgeously
pictures.
beautiful.
One day.
Put it on your bucket list. Anyway, I've been
It
seeing
already
your
is.
name and I had to ask. You have a good day, all right?
Too. Thank you. Bye bye.
Bye.